So good afternoon, everybody, and thank you for being with us today. So welcome to the fourth and last webinar of the AMFEP-FEDIMA series on the safe handling of enzyme in the bakery supply chain. Most of you online today probably also followed our previous webinars held in October and last week. If you missed them, no worries, you can find the recording on our website. My name is Céline Benini, and I'm working as Regulatory Affairs Manager in the Secretariat of AMFEP, based in Brussels. I'm happy to introduce this webinar series on behalf of our two organizations, AMFEP and FEDIMA. These joint industry initiatives aim at bringing together the insights, best practices, and tools from the producers of enzyme, AMFEP, and the users of enzyme in ingredients for baking industry, FEDIMA, in order to control dust exposure in the workplace. Our common goal is to help safeguard the health of workers. AMFEP and FEDIMA have been collaborating for years on education and improvement of handling of raw material and ingredients that contain enzymes. One of the main outcomes are the industry guidelines on the safe handling of enzyme in the bakery supply chain, which were published in 2018. This webinar series is largely based on those guidelines. As you can see in the program, this webinar series is split into 4 sessions, each one addressing specific subjects from the industry guidelines. We believe that these webinars are relevant for a large target audience, including SHE, WHS, and OHS managers, all plant operationals, R&D employees in the bakery sector, program manager and teacher in bakery education centers, representative of occupational health and safety organizations, artisan bakers, bakers union representative. Please note that this webinar is being recorded and will be available on our websites as a tool for continued education. Let us now briefly present AMFEP and FEDIMA. So AMFEP is the Association of Manufacturers and Formulators of Enzyme Products. It has been created in 1977, and since then, AMFEP has represented and promoted the interest of the enzyme industry, now equating to more than 90% of the European enzyme market and 80% of the world enzyme market. AMFEP members are producers of enzymes destined to the technical, the feed, and the food industry. And through our activity, we promote the safe use of enzyme, their sustainability aspect, and their contribution to innovation. FEDIMA is the Federation of European Manufacturers and Suppliers of Ingredients to the bakery, confectionery, and patisserie industries. They currently have 12 members as national association in Europe. FEDIMA members produce a range of intermediate products to bakery and pastry professionals. Hence, they are a business-to-business sector. FEDIMA mission is to promote a favorable environment for the sector, which in turn can support a sustainable and innovative bakery industry. As you can see in the blue box, occupational health and safety is one of FEDIMA's 4 key areas of activity. Others are informed customers and consumers, food safety, and bakery sector promotion. Our collective goal as AMFEP and FEDIMA is to work on the control of occupational enzyme exposure in the bakery sector. We do this by developing practical, user-friendly materials for the bakery sector, which combines the expertise of both our organizations. We have developed several materials which you can see listed on the right side of the slide. These are available on AMFEP and FEDIMA websites. We will elaborate on the materials later in this webinar. Before we start, a few words of clarification. So the information we will present in this webinar series is furnished free of charge and is based on information that AMFEP and FEDIMA and our members believe to be reliable. It is intended for use by persons having technical skills and at their own discretion. Since conditions of use are outside our control, we make no warranties and assume no liability in connection with any use of this information. Nothing in this webinar series is to be taken as a license to operate under or recommendation to infringe rules. Our materials only address the control of occupational exposure among the workforce, not toward consumer, as this exposure is practically non-existent. Please note that in cases where some brands are included in this presentation, they are only provided as example, and there are other brands on the market that are available with the same technical functions. So AMFEP and FEDIMA do not recommend any brands in particular. So today's webinar is, as I said, the fourth and last in our series. It will focus on health surveillance and hair monitoring. It will be presented by Mariette Simonsen and Christian De Vos. After the presentation, there will be time for Q&A, and you can submit your question through the chat function during the webinar, and we will ask you if you could please send your question to the Q&A user so we can collect the question. We will try to answer to as many as possible, but if we don't manage, we will provide answer in writing after the webinar. So without further delay, I'll give the floor to Mariette and Chris.
Thank you, Celine. Good afternoon, everybody, and thank you for being with us again today. This webinar follows on from our initial introduction to enzyme safety, presented by Mariette Simonsen from Novozymes. On enzyme handling in artisan bakeries and bakery schools by Maria Coutinho and Bas Verhagen from Puratos. And enzyme handling in industrial bakeries by Sarah Houghton from De Safre and Martin van Noord from AB Mauri. In the interest of time, we would like to answer your questions only at the end of the session. So in order not to forget, please note any questions that you have as we go along. On the next slide, you see the outline of today's webinar. We will start off with a session on the medical perspective of working with enzymes, presented by Mariette Simonsen from Novozymes. In this session, we will make a short recap on some of the information given in the introductory webinar, and then go more in details on medical surveillance. This session will then be followed by a session on enzyme exposure monitoring, presented by myself. In this session, the full picture will be given on how to plan for enzyme exposure monitoring, which equipment to use for air sampling, etc., and how to analyze the amount of enzyme dust collected on the filters in the air samplers. But first, let's look at the medical perspectives. Mariette, it's up to you.
Okay, it appears that I'm unmuted now. Okay, hello everyone. I would like very much to have the next slide. My name is Mariette Simonsen. I'm working for Novozymes, and I have been focusing on safe handling of enzymes for the last 20 years or more. I will start my part of this session by giving a quick recap on the most important issues that was presented in the introductory webinar. Enzymes are widely used in the baking industry due to their valuable and very specific activities. But what are they? Enzymes are proteins which are naturally produced by all living cells. All living organisms, whether human, animal, plant, or microorganisms, need enzymes to conduct the physiological processes which are essential for growth and life. Enzymes act as catalysts, substances which, in very small amounts, are able to significantly speed up the rate of a specific chemical reaction. For example, the building up or breaking down of organic matter, such as carbohydrates, fats, and other proteins. Enzymes are highly specialized in their functionality, with each enzyme acting only on a restricted number of substances and only catalyzing one specific reaction. For example, the starch-degrading enzymes, the amylases, which are present in human saliva, break down starch into smaller molecules, which can then be degraded and absorbed when entering the gastrointestinal tract. Additionally, enzymes are beneficial to the environment as they are biodegradable and water-soluble, and also they are generally non-toxic. It has long been known that flour dust and enzymes used in the baking industry can cause respiratory allergy. Flour dust is known to cause allergy and baker's asthma when exposure is not well controlled. The allergy from flour dust is caused by one or more of the approximately 40 different protein allergens that are natural constituents of flour. Enzymes are also proteins, and as with other proteins, they may act as respiratory sensitizers if individuals are repeatedly exposed to airborne dust in which they are contained. Such sensitization may ultimately lead to respiratory allergy, but it is important to note that not all individuals who become sensitized to enzymes develop symptoms. Similar risks are posed by other ingredients used in the baking industry, for instance, wheat flour and other additives, which may also induce respiratory sensitization and allergy. However, it is important to note that it has been demonstrated that the potential for this respiratory sensitization and allergy can be controlled by proper process controls, product formulation, and adherence to appropriate handling instructions to prevent airborne dust or aerosols. Like many other proteins, enzymes may act as allergens via inhalation. A two-step process must take place for the development of an inhalation allergy. Initial sensitization, which is also called induction, and then followed by elicitation. As a first step, airborne exposure to the enzyme needs to occur. If this exposure is sufficiently high in terms of concentration, duration, frequency, etc., this may lead to sensitization in some individuals. At this stage, the immune system of the individual will be activated in such a way that specific antibodies towards the enzymes are formed. However, the individual does not suffer from any allergy symptoms. The formation of the specific antibodies can be detected in a blood sample, and it is important to note that not all individuals exposed to the airborne enzyme will become sensitized. A sensitized person has no symptoms, and sensitization in itself is not a disease. Sensitization is the early warning that an allergy may develop. If the sensitized individual continues to be exposed to airborne enzyme, then an allergy may develop. At this stage, the individual will develop the symptoms typical for respiratory allergies, such as hay fever, and some individuals may develop asthma upon continued exposure. When this condition is due to exposure in the working environment, it is called occupational allergy. Again, it is important to note that even among sensitized individuals, only some of them will develop an allergy. Looking at the flow presented on this slide, it seems obvious that if exposure is in control, then sensitization will almost never occur. In addition, if the workforce is part of a medical surveillance program, a sensitization will, in most cases, be detected before it develops into an allergy. The respiratory symptoms from allergen exposure may include itching of the nose and eyes, nasal and sinus congestion, and sneezing. Coughing, hoarseness, tightness of the chest, and shortness of breath are all indicators of asthma. These symptoms may occur during or after working hours, and they disappear within hours or within a few days after the exposure has ceased. Allergy symptoms may be similar to those of a common cold, and if such symptoms occur frequently at the workplace and only rarely at weekends or during holidays, they may be the result of an occupational enzyme exposure. Allergy by inhalation caused by flour or enzymes is similar to the respiratory allergies that are caused by well-known allergens like grass pollen, house dust mites, or cat dander, and the symptoms are also similar. An allergy always starts with the milder symptoms like persistent sneezing or runny nose. If the individual continues to be exposed to the allergen, the more severe allergy symptoms like coughing or asthma may develop. These are symptoms that will have a huge impact on life quality of the individual. These more severe symptoms can be prevented if a medical surveillance program at the workplace is installed. A medical surveillance program at the workplace will identify workers who are sensitized and workers having symptoms, and it will follow up on the sensitized and allergic workers, enabling intervention if new symptoms should appear, thereby protecting the worker from experiencing the more severe symptoms. There are other forms of allergy besides the allergy caused by respiratory exposure, such as skin contact allergy and food allergy. There is no specific scientific evidence that enzymes are associated with allergy caused by skin contact or by ingestion. Some people are defined as atopic, which means that they have allergy towards one or more of the common allergens like pollen. For years, it has been discussed whether atopic individuals are at higher risk for developing allergy, but until now, there is no clear answer to this. Smoking has been identified as a factor which increases the risk of becoming sensitized and of developing symptoms. In addition to this, it appears that individual susceptibility may vary from time to time. For instance, returning to work after a recent infection seems to increase the risk of becoming sensitized or of developing symptoms. An enzyme allergy is exclusively an occupational health hazard for people working in the enzyme manufacturing industry or for workers handling enzymes as raw materials in, for instance, the baking industry. Several studies have shown that consumers using the enzyme-containing products on the market today, or consumers using products that are manufactured with the use of enzymes, are not at risk. Hence, an enzyme allergy, is a result of an occupational exposure, and the cause of it should be found in the working environment. The main purpose of health surveillance in this context is the periodic medical examination of all workers. The objectives of health surveillance related to enzyme exposure are to protect the health of the individual employees by identifying as early as possible any adverse effect which may be caused by the exposure to enzymes, to give guidance based on a medical assessment on how to continue working in an environment where enzyme exposure may happen, to assist in the evaluation of measures taken to control enzyme exposure, and to collect and maintain objective data to detect and evaluate hazards to health. A health surveillance program can be established by internal or external resources, and it should encompass all exposed employees at the workplace including temporary workers. The health surveillance program must include a pre-employment screening and a regular screening each 6 months for the first 2 years of employment, and after that, a screening each year. In this webinar, we focus on health surveillance to enzyme exposure, but the principles discussed here can be applied to other respiratory allergens in the working environment as well. Before starting to work in an environment where enzyme exposure cannot be excluded, a pre-employment or pre-placement testing should be conducted. Such pre-employment testing should include a medical history with particular reference, for example, to asthma, allergic rhinitis, allergies, chronic lung diseases, and any medication. A completed respiratory questionnaire, an assessment of lung function, immunological test, for instance, a skin test or a serological test, and a physical examination which may be carried out at the discretion of the occupational health professional. During the first 24 months of employment, individuals should have a 6 monthly health surveillance, and thereafter again at a minimum of every 12 months. The review should include periodic respiratory questionnaire, lung function test, and immunological tests. The outcome of the regular testing may be divided into the following options. Those with normal findings may continue to work until the next regular examination. Those who have developed a positive immunological test should test result to an enzyme but have no other adverse findings may continue to work with enzymes, although increased frequency of surveillance of such workers may be appropriate. Those with abnormal findings to the respiratory questionnaire, which could be due to enzymes, and those with impaired lung function require immediate further assessment and should be retested within a month or as assessed by the occupational health professionals. Those who show a continuing downward trend in lung function should be assessed as to the need for their removal from further work with enzymes. Employees with clinical symptoms of enzyme-induced respiratory disease should have their fitness to work assessed by an occupational health professional. And finally, employees should be trained to recognize symptoms that may be related to enzyme exposure and encouraged to report such symptoms to the occupational health center. The results of an individual's immunological test should be given to each employee via the company doctor or external medical professional. They are of practical relevance for the individual employees since they may help the identification and correction of individual factors that can contribute or even cause the exposure leading to the sensitization, such as failure to follow safe working practices. Each case of sensitization should be evaluated by a workplace investigation conducted by an occupational health specialist. Additionally, group results from immunological tests also assist in the evaluation of workplace control measures. Group data should be used to monitor the effectiveness of hygiene and engineering programs at factories and within individual departments. Such data will help to prioritize areas for improvement. As mentioned before, the 3 pillars in medical monitoring of respiratory allergens are the questionnaire, the lung function test, and the testing for sensitization. The industry guideline on the safe handling of enzymes in the bakery supply chain has a brief description of these 3 pillars. A more comprehensive description can be found in the similar guideline for the detergent industry, which can be found on the website of their industry association called AISE. It is anticipated that applicants for a job will complete a general health questionnaire at pre-placement, and that this questionnaire will include questions relating to previous employment and any exposure to chemicals, fumes, or dust. The intent of the pre-placement respiratory questionnaire is solely to detect existing respiratory symptoms and to give a good description of such symptoms. In addition, a new questionnaire should be completed at the regular or periodical testing to follow up on any change since the last testing. When performing a lung function test using spirometry, it is important that an accepted standardized procedure and protocol is followed to reduce measurement errors. Furthermore, spirometry should be conducted by trained and competent staff, since testing and interpretation require both skills and training. The parameters to be measured are forced expiratory volume in 1 second, which is called FEV1, and forced vital capacity, which is called FVC. And finally, the ratio between FEV1 and FVC. The forced expiratory volume in 1 second is a volume of air that can be forcibly blown out in 1 second after full inspiration. In healthy people, the average value of this parameter will depend mainly on gender and age, as well as height and mass. Values between 80% and 120% of the average value are considered normal. Forced vital capacity is a volume of air that can be forcibly blown out after full inspiration. In healthy adults, the ratio between FEV1 and FVC should be approximately 70 to 85%, declining with age. In obstructive diseases like asthma, the ratio between FEV1 and FVC is reduced, often down to 45%. Peak expiratory flow rate, PEFR, is the maximal flow or speed achieved during the maximally forced expiration. It is measured in liters per minute or in liters per second. A minimum of 3 trials should be completed to check for reproducibility. Once acceptable and reproducible spirometry results have been obtained, the results should be interpreted by a trained and competent person. The purpose of immunological monitoring is to monitor the appearance of sensitization among the workforce. That is, to monitor the development of specific IgE antibodies. It is important to remember that sensitization is not in itself a disease. It is an indication that a person has been exposed and may be on their way to developing an allergy. It is possible to prevent the development of an enzyme allergy by monitoring the immunological status of the employees and by the subsequent intervention where necessary. 2 methodologies are generally used for monitoring the immunological status among employees. These are skin prick test as shown in the picture, or serological test, which is an analysis of a blood sample. Both methods are robust for monitoring the immunological status of an individual. However, both methods also have advantages and disadvantages. For skin prick testing, it is a big advantage that the result is obtained almost immediately and that the method is relatively inexpensive. The disadvantage of this method is that it requires a high level of training and skill of the staff conducting the test. A further disadvantage is that this method does not produce a quantitative result. a simple yes or no response is obtained with regards to sensitization towards the allergen in question. The major advantages for serological testing are that the results obtained is quantitative, that analysis of additional allergens can be conducted on the same blood or serum sample, and that the serum sample can be stored for analysis at a later point in time. The latter could be relevant if, at some point, it becomes necessary to investigate for sensitization towards another allergen that was not previously investigated. Serological testing does not require specially trained nurses or staff on site, but it does require the serum samples being transported to an accredited or certified laboratory. Using an accredited or certified laboratory is important, as otherwise false positive or false negative responses may be obtained. It is a disadvantage of the serological testing that the results of the testing is not obtained immediately. The fact that the serological testing is relatively expensive may also be considered a disadvantage. One important thing to keep in mind for both skin prick test and serological testing is that the access to a purified preparation of the allergen is required. For skin prick testing, you need to be sure that the preparation used for testing consists of the enzyme in question and nothing else. The same goes for serological testing, that setting up such a test requires access to a pure preparation of the enzyme. If uncontrolled preparations are used for these tests, then false results may be obtained. Ask your enzyme supplier for pure enzyme preparations that are suitable for such tests. The relationship between airborne exposure to enzymes and the development of sensitization or allergy is today only poorly understood. The reasons for this lack of knowledge are many, but among the most important are the facts that we do not have any animal models which could be used to provide information on this relationship or to provide information on a no effect level. Most data on human exposure to enzymes are based on exposure monitoring for 4 to 8 hours in a specific area. This type of data does not allow for peak exposures to be identified, and hence the contribution of such peak exposures is not really accounted for, although it is generally recognized that peak exposures play a vital role both for sensitization and allergy development. On the other hand, we do have some knowledge on the relationship between airborne exposure to enzymes and the development of sensitization or allergy. We definitely know that when the exposure is in control, this will lead to a reduced number of sensitizations and result in only a low risk of symptoms. It has been shown that among the exposed workers, some may become sensitized, but only a limited number of these sensitized persons will go on to develop an allergy. In addition, it appears that the development of allergy occurs at higher exposure levels than the exposure levels required for developing a sensitization. In Europe, the REACH legislation has requested an enzyme exposure limit to be established. This limit is called a DMEL value, and it has been set to 60 nanograms per meter cube. From the enzyme manufacturing industry and from the detergent industry, we know that complying with this exposure limit will provide an adequate protection level of the workers. The main conclusions to be drawn from this presentation are that a health surveillance program should be established when occupational exposure to enzymes may occur. The health surveillance program can identify workers that have become sensitized. Intervention and close follow-up on sensitized workers may prevent them from developing allergy, and in cases where allergy symptoms are already present, that these symptoms become more severe or even chronic. A health surveillance program with high participation rate may provide group results that can help in documenting a healthy workplace or to identify area-specific issues related to equipment, processes, ventilation, behavior, etc. Good communication with employees is vitally necessary to harvest all the benefits from a health surveillance program. Employees may not want to participate in a health surveillance program or to come forward if they should experience any allergy symptoms, unless there is a good and positive contact with the management and occupational health team.
Okay, thank you, Merete. Good afternoon again for explaining this part of the enzyme safety program. I'm Chris Vos, EH&S manager for DuPont Nutrition and Biosciences based in Belgium. I've worked already for more than 30 years in the company, and I conducted a lot of air monitoring at both our own production sites and at customer facilities. What are the objectives of this webinar now? I think the objectives should be clear. We need to understand where the engineering controls are inadequate to control enzyme dust and aerosol concentrations to an acceptable level. At those places or activities, people should wear a P3 respirator or even a PAPR, which is a powered air purifying respirator, when exposures are way too high. Please check with your suppliers the nominal protection factors of your respiratory protective equipment. The assigned protection factors may be even 2 to 5 times lower. It's clear that our goal here is zero sensitizations. In one of the next slides, I'm going to talk also about the challenges of the air monitoring program. When should we conduct air monitoring? If you look at this slide, generally speaking, enzyme air monitoring should be prioritized based on the risk of exposures of workers. That's key. Firstly, we can start with a qualitative assessment of the risk, as these data will be the input for designing the site's air monitoring strategy. It's clear that the strategy will also be dependent on the outcome of any medical surveillance, as explained by Merete before. For example, if immunological testing reveals an increasing trend in the incidence of sensitization. In addition, the strategy will also depend on the outcome of any performance assessment of the equipment, the working practices, and also important behavioral aspects. Most importantly, which exposure limit are we going to monitor against? This will be covered in the next slide. And for those who have also attended the first webinar presented by Merete Simonsen, this will be a reminder. At present, occupation exposure limits for only one enzyme class, namely subtilisin, have been established by regulatory agencies. Subtilisin is a class of proteolytic enzymes. A limit of 60 nanograms per meter cube based on at least 1 hour sampling was set by the American Conference of Governmental Industrial Hygienists and has been adopted by several countries. The EU REACH legislation covering the technical applications of chemicals, including enzymes, requests the establishment of a no effect level, also called a DNL, for all substances classified as hazardous and registered for more than 10 tons per year under this legislation, where a no effect level cannot be established properly due to the characteristics of the hazard, a minimum effect level, also called a DMEL, must be established. For enzymes, such a DMEL value has been established to be 60 nanograms per meter cube. In the period from 2014 to 2018, the class of alpha amylase enzymes, which are extensively used in the baking industry, was evaluated under the REACH regulation, first as a CORAP evaluation, CORAP standing for a Community Rolling Action Plan, and subsequently as a risk management option analysis called RMOA. The overall conclusion from these evaluations was that enzyme exposure must be in control in all industries and for all enzymes, including baking and other food industries. One reason for mentioning the baking industry is that approximately 80% of all registered allergies to alpha amylase come from the baking industry. By expanding the scope to all industries and all enzymes, the DMEL limit also covers the use of enzymes in the baking industry for EU countries. In the Netherlands, an OEL for alpha amylase of 10 nanograms per cubic meter has been recently established. The proposal was submitted by the SER, the Dutch Social Economic Council, to the Minister for Social Affairs and Employment. The implementation deadline is January 1st, 2024 for artisanal and industrial bakeries, and January 1st, 2029 for the bakery raw materials industry. In the meantime, AMFEP and FEDIMA liaised with the NEBAFA in order to encourage them to contact the Dutch State Secretary for Social Affairs and Employment to obtain clarification, notably on the scope of the regulation, which seems to have been extended to all alpha amylases without support of feasibility studies. This would mean that, while at first only the baking industry was concerned, this has now spread to the whole food industry. Besides that, other unclarities have to be resolved by the Dutch State Secretary. So definitely something that we need to follow up on. Besides OELs for enzymes, most countries within the EU have a limit for the overall dust level, including flour dust. The level varies somewhat from one country to another, but an overview of existing limits can be found in the industry guideline on the safe handling of enzymes in the bakery supply chain. Here you can also find a list of the regulatory exposure limits for subtilizing. In the Netherlands, also an OEL of 1.2 milligrams per cube for flour dust has been established, expressed as an 8 hours time-weighted average, effective as per January 1st, 2020. So already within about a month from here. As this was a quite busy slide, I hope you're still with us. Anyway, who should be playing a role in an air monitoring program? Several players are involved in the program. Trained resources, preferably industrial hygiene specialists, are needed for the sampling, but trained lab technicians also play an important role, as the analytical work is of equal importance. These are the most relevant components of a sound air monitoring program. I'm coming back to this later, but don't forget to involve also your employees on the work floor, as they know best what's going on. They can be extremely useful as part of the monitoring team because they will help to communicate monitoring results to the employees, especially when it comes to defending unpopular measures such as the mandatory imposition of the use of respirators. Training of the monitoring team is very important. I have to say that even after doing this job for more than 32 years, I'm still learning every day. The biggest risk here is the contamination of a sample. Please remember that the objective is to measure nanograms of enzyme, which is billions of a gram. High flow sampling filters are especially susceptible to contamination because the filters are not housed in a cassette and have a large surface area exposed to the environment. This in contrast to the 37mm filter cassettes. Tweezers and high flow filter housing should be cleaned with ethanol between uses. As these elements may seem technical, I will clarify them with pictures in the next slides. Another important aspect of training is the sampler calibration, but we'll come back to this also later in more detail. As to the equipment, the choice between high or low volume sampling depends on the purpose of the monitoring and the duration of a certain activity. If the process varies in a manner that could create peak exposures over a short period of time, for instance, filling a hopper with a granulated enzyme formulation that discharge enzyme dust or aerosols at the opening or tank vents, the use of a 25-liter sampler or a high volume pump might be more appropriate. For personal sampling, due to the size of the samplers, the 2 to 3 liter per minute samplers are the only option. So here are a couple of bullet points indicating the particularities of high volume samplers. These samplers are mainly used to identify peak exposures, as the sampling time can be as short as a couple of minutes, because the LOD, or the limit of detection, is not an issue here. However, the 25-liter samples that are shown in one of the next slides are also capable of identifying peak concentrations, which could lead to unacceptable inhalation exposures for the workers involved in that specific activity. Here, the sampling time would be rather in the order of 10 to 30 minutes. A couple of pictures. You see here on the picture at the left a new version of the galley sampler, which was one of the first samplers used. The height of the filter is set at the average height of an operator, just over 1.5 meters, and the filter head is precisely manufactured so that the speed of air flowing into the filter is similar to the speed of air being breathed in. For most samplers, the filter is also shielded from excess contamination by a hinged plate. As to the low volume samplers, the big advantage here is the portability of these pumps, also because they do not necessarily require an external electrical source for operation. The device at the right side of the slide, running at 25 to 30 liters per minute, enables us to assess targeted exposure measurement or peak exposures, keeping the sampling times quite limited, and with the advantage of the portability, allowing sampling at otherwise difficult or inaccessible places. However, you can also connect them to a nearby electrical outlet. As I said before, careful calibration of the equipment is crucial for the reliability of the results. Pumps must be calibrated before and after sampling with the sampling media in place to verify that the sampling rate remained constant. It's a good practice to discard samples if the flow rate changed during the sampling by more than 5% of the initial flow rate. In this picture, you can see what the calibration and sampling train configuration could look like. For the sampling itself, the intake of the high volume pump should be directed towards the most likely source of enzyme exposure. Filter sets should be angled downwards towards the floor during low flow sampling to prevent contamination from large particles. What about the air sampling plan? As we have already mentioned, involvement of the plant operatives in the execution of the air monitoring program is crucial in order to really understand what's going on in the plant. It's not uncommon for enzyme concentrations to differ drastically from previous results because of changing environmental conditions or changes to any part of a local exhaust ventilation system. I have seen cases where under pressure was created in an otherwise clean area due to the installation of a biosafety cabinet. This led to the intake of contaminated air from an adjacent production area because the supply of make-up air wasn't anticipated in the project. This is a typical example of a failing management of change. It's not unusual for an occupational hygienist who is not necessarily involved in daily plant operations to have overlooked this. And it's a typical example of why we need people from the factory floor to be involved. This slide gives you an overview of the 3 sampling approaches that may be used, although you might be pushed by authorities or guided by EN standards to opt for personal monitoring. We believe that personal bleeding zone sampling is not necessarily the preferred method for enzyme exposure monitoring, for a couple of reasons. First of all, personal samples will not necessarily identify peak concentrations, adversely to high volume area or static sampling and point source sampling. Secondly, operators nowadays are working more and more from control rooms, are multitasking, hence not necessarily staying for the full time at the defined sampling location. And finally, personal monitoring doesn't provide a useful way to ensure engineering controls such as containment and local exhaust ventilation are working effectively. Here is a slide about the typical sampling locations. Besides those highlighted here, which are typical for a bakery or a bakery ingredients plant, it's also of vital importance to focus on non-routine activities, such as troubleshooting, rework activities, handling of enzyme packaging waste, hence all activities which may create peak exposures, in contrast to normal routine activities, where exposures are generally well controlled. Data interpretation is perhaps the most difficult part of the whole exposure assessment. Firstly, do you want to use this data for decision making with regards to capital investment, which may be needed to improve engineering controls? Secondly, do you want to use this data to motivate people into wearing the necessary respiratory protective equipment? The data from each specific location or activity should be analyzed separately as its own data set. How is the CPK interpreted? CPK standing for capability ratio. If the average of 3 or more measurements plus 3 standard deviations provides a value less than 60, this means that the CPK is greater than 1. The dataset can be considered as valid and suggests that respiratory protection is not required in that area or for that task. As referred to in former slides, I cannot emphasize enough the need to get your operators involved in this program. Their cooperation is especially helpful in getting potentially unpopular measures adopted by the whole workforce. For example, the mandatory use of respirators. At the beginning of this webinar, I informed you I would come back to address some challenges. So far, the development of real-time analyzers has been a challenge. Working prototypes have been constructed, although they didn't really pass the commercialization phase. With the actual tools and analytical methods available, we are always behind the facts. Therefore, it can be difficult to trace back to what really went wrong at the time of sampling. Other challenges are reflected in the other bullet points and are obvious. One aspect of exposure monitoring is the sampling, but the analysis is equally important. We are referring to the two common methods, of which the activity-based assays will still be the most practical one, particularly for small and medium enterprises. Please ask also your enzyme supplier for analytical methods for customers. Regarding activity-based assays, these are easy to set up and run, but the higher LODs may be a limiting factor. Enzyme activity assays may also lead to false negatives, as inactivated enzymes may still be allergenic. The analysis of the so-called blanks is important to establish the validity of the air monitoring results. Blanks are analyzed to rule out sources of contamination and analytical error. A buffer blank should be collected on every day that the buffer is used. At least one filter blank should be analyzed to rule out any contamination of the filter stock. Preferably, air monitoring filters require prompt analysis. Enzyme activity decreases over time, so that filter cassettes should be refrigerated at 4 degrees C for the first 2 weeks and stored as low as -20 degrees for the long term. Best practice for the storage of filters should be available in the validated SOPs for the air monitoring assay developed by your enzyme suppliers. ELISA assays rely on the binding of the enzyme to specific antibodies in order to quantify protein levels. They also provide a more toxicologically relevant measurement. Although ELISA techniques are able to achieve very low detection limits, this requires additional equipment and specialized training, so they are a less obvious choice for normal production quality control labs. A quite new analytical technique has recently become available for fungal alpha amylase. It is called MICT, and it's a kind of a qualitative pregnancy test. That is, it uses the same principles as in a pregnancy test, except this one will give a quantitative answer. It needs to be emphasized, though, that the antibodies are specific for the enzyme. the assay needs to be validated for each commercial fungal alpha amylase. Whereas ELISA requires specially trained personnel, the MICT can be conducted in any laboratory setting. And whereas ELISA will require several hours to provide a result, the MICT can do this in 30 minutes, so much quicker and easier technology. More information on the MICT can be found on the internet. Let's also talk about the characteristics of enzyme raw materials, particularly the dustiness. As the quality of the enzyme encapsulate may be a predictive tool for an initial evaluation of the exposure risk at the plant, it should be remembered that the level of enzyme exposure in the working environment depends on many factors, so cannot necessarily be extrapolated solely from the dustiness data. And here is a picture of the Heubach instrument. Please be aware that cleaning of the Heubach instrument parts may create aerosols. We have measured levels up to 143 nanograms per cube during sample preparation and cylinder cleanout. So please take suitable precautions. Compressed air cleaning is a documented risk factor for enzyme exposure. This concludes the exposure monitoring part of this webinar. I hope you are still with us. On this slide, you can see the most important reasons for why an exposure monitoring program should be implemented if enzymes are used as raw materials in a production plant. Not only is an exposure monitoring program essential in documenting compliance to an exposure limit, but it is also essential for providing a safe working environment for the workers and for keeping the working environment safe. This concludes the webinar on health surveillance and air monitoring. Of course, it's not possible to cover everything in detail in such a short time, but hopefully what we have presented today has provided you with useful information and given you some food for thought. We also hope that this webinar, together with the others, will help you to assess your business and working practices and encourage you to implement the necessary measures to control dust exposures. In addition to the guidance document, other information may be found on the AMFEP and FEDIMA websites, as well as on the other websites shown at the bottom of this slide. Please remember that you also can provide direct safety information to your workforce by putting up the safety poster that AMFEP and FEDIMA have prepared in a visible place in your production area. Thank you for your attention.
So thank you very much, Merete and Chris. We will now try to answer some of the questions that we were asked during this webinar. Please remember that you can still type your question in the chat box. So now we will take just a minute to collect all the questions received, and then we will start again. So please stay tuned.
We got one question here. We do not use pure enzymes. Enzymes are always diluted in mixes. Should we conduct a medical screening as well? Merete, this is more a health-related question. Can I give this to you, Merete?
Certainly. My answer would be yes, because I mean, of course, if the enzymes are present in only very dilute form, then the exposure would be equally lower than if you are using pure enzyme material. However, we know that certain operations, even though that they are produced by diluted or mixes where enzymes are included, are able to provide exposures that will exceed the 60 nanograms per meter cube. So, in my opinion, I would start off by measuring the exposure in such environment, and based on the data that I received there for the various operations, I would consult the enzyme supplier to discuss whether a medical surveillance program would be needed or not.
Okay, I hope this was clear for the audience. I see here another question. The MICT is calibrated only for fungal alpha amylase. What are the options for other enzymes or other alpha amylases? I think I tried to explain that when presenting this slide. And it's also mentioned on the slide that we need to emphasize that the antibodies that have to be prepared are specific for the enzyme. So the assay needs to be validated for each commercial fungal alpha amylase. That would be my brief answer. But definitely you can go on the website, contact the company, and ask for further help in this. Okay, for the moment, I don't see any other questions.
Oh, I do.
You still have, yeah.
I see a question on, let me see, what is the percentage of sensitized people working with enzymes that may develop an allergy? Well, very roughly, the knowledge we have from the enzyme manufacturing industry as well as from the detergent industry is that very roughly 10% of those who are exposed will develop a sensitization. And among the sensitized people, 10% will develop symptoms, that is, become allergic. So, roughly speaking, of the exposed population, 1% will at some point in time develop an allergy. That is the knowledge we have for the moment being from the enzyme manufacturing industry and from the detergent industry.
Okay, thank you, Merete. I see here in the meantime another question popping up. Mm-hmm. Can liquid enzymes cause an allergy? Well, I think the answer is clear, yes, because liquid aerosols can be inhaled as well. And well, I would even say don't underestimate liquid aerosols, because if you have a spillage in the plant and if you don't use the appropriate measures to clean up the spill, you can create a lot of aerosols. And if the person that is cleaning up the spill is not properly protected, he or she would really also expose to unacceptable levels.
Okay, Chris, I have another question here.
Yeah.
If you become allergic to one enzyme, are you then allergic to all? The answer is no. the specificity of the IgE antibodies are very high. So the IgE will only react to one specific allergen. So it is to compare. If you are allergic to grass, you are not automatically also allergic to cat dander. However, some of the enzymes used in the industry have a very close relationship. And in that case, they may, as we call it, cross-react. And in that case, if you are allergic to that enzyme, that specific enzyme, then you will automatically also react to the very close related enzyme. But in general, you will not see these cross reactions between classes. So if you, for instance, are allergic to amylase, you will probably not be allergic to silonases or cellulases or whatever classes of enzymes are used in your workplace.
Yeah, and perhaps I can confirm this by my personal experience. Myself, I'm allergic even to house dust mites, and I have been exposed for more than 32 years to enzymes, and I never got sensitized to enzymes. So I think this is the best example to answer this question. Yeah.
Yeah. I have one more question here. Can one become allergic by eating bread made with enzymes? And again, the answer is no. Apparently, the allergenicity of the enzyme is destroyed during the production of the bread, probably during the baking. And we have studies showing that even if you have people who have become occupationally allergic to fungal alpha amylase, then when they eat bread baked with a double doses of fungal alpha amylase, they do not react to that.
Okay, I see here a question. What if a new employee is sensitized? Can they still be hired? I would say yes, because it's not a condition, or sensitization is not a condition for employment, and it would be yeah, not well perceived, I think, and certainly not according to our national legislations if we would not allow a person who is sensitized to start working.
Yes.
Okay.
What if an employee gets sensitized? Do they have to stop working with enzymes? I think it's very much along the same line as what you just answered, Chris. No, they should not necessarily stop working with enzymes. It depends on their health status and how fast this sensitization has developed. So it will be up to the medical staff to decide whether this is an example where you should remove the worker from working with enzymes, or whether you could still keep the worker in contact with enzymes but have a very close surveillance of these employees. So that will be up to the medical staff.
Yeah, then one on the monitoring. Do you need to monitor all different enzymes used? Well, I would say not necessarily, because we believe that enzymes are behaving in the same way, at least if they are used in the same way for the same applications and the same equipment. So I would say no. I think if you have good set of data points for one enzyme, you have to look definitely also at the concentrations in your premixes or whatsoever. So try to also monitor the worst case conditions. That would give you a good idea of what the potential exposures could look like. That would be my short answer.
Yes.
I see here a last one. What is an appropriate cost range for an air monitoring equipment? Well, it depends also a little bit on the type of equipment, and if you limit yourself to just high volume sampling or low volume sampling. From my experience, one sampling pump would be in the order of, let's say, about 600 euros on average. But yeah, one pump is not that much, but you can definitely start already with. You also have to buy the filter cassettes or the IOM samplers or the button samplers. This is a little bit minor compared to the sampling pump. Altogether, I think equipment-wise, I'm talking only about taking the samples, not the analytical work yet. Well, with 1,000 euros, you can do already first quick assessment. But yeah, definitely if you would like also to go on buying high volume samplers, these would be more in the order of 2,000 to 3,000 euros. Don't forget also then to have some calibration equipment ordered. Could be also in the range of 1,000 to 2,000 euros, depending on is it for low or high volume sampling. But don't forget, you don't necessarily have to do everything by yourself at the first moment. From my experience, and I have used also external companies that are specialized in occupational hygiene that can do the job, that have the equipment available. So maybe if you have to do your first quick exposure assessment, well, one option could be asking help maybe to your enzyme suppliers who could help you setting up the program, but also going to external providers who can do the job.
So
Okay, maybe, I don't know if we have time for more, Celine.
maybe one last.
Maybe one last. Let me see if we have any more.
I think we have answered them all, Merete, from what I see here.
Yeah, great.
Yeah.
Okay. So, well, this concludes the AMFEP and FEDIMA webinar series on the safe handling of enzyme in the bakery supply chain. We hope that our webinar met all your expectations, that you found the topics addressed relevant. Thank you again for your participation, and please don't forget that the recordings are available on our respective websites. In a few weeks, we will upload Q&As for the 4 webinars on the AMFEP and FEDIMA website, so you will have access to the question and answer addressed during this series. Before closing, we would like to also thank our partner for their support in promoting this webinar series. So thank you very much to all of you, and have a nice day.